Welcome to lesson 111 of algebraic concepts. Solve equivalent systems of linear equations. So let's see what's different about this. Okay, so here's our objective, our vocabulary, and our rules and notes. So make sure that you pause the video and read through these things. I won't do that on the videos to get a foundation or an understanding of what we're doing in this lesson. All right, so here's the point again. Solutions of systems of equations. I think this is the 7th video in a series of 8 dealing with systems of equations. I started with graphing, and then I went through substitution and elimination, and now we're doing equivalent systems. So I don't know how you're going to learn this. They may mix this in. Your teacher may mix this in with elimination. So I separated them all out because you will be doing them at different times. So what is the point of systems of equations? We're looking for the point of intersection. The point of intersection. So we're looking for this point if there's a solution. If there's no solution, the lines will intersect, and an infinite solution means that the lines are the same. So let's go through it. All right, solve the system. So because these are both in standard form is ax plus by equals c. Because they're both in standard form, we would look to do the elimination method. Okay, but if we look at our coefficients, 2 and 5 and 1 and 3, they're not the same. So what you're going to have to do is multiply the whole equation to make the coefficients the same. And we're going to use y. We're going to eliminate y because it's easier to multiply one equation than to multiply 2 in my mind. So 3 is going to distribute to everything inside the parentheses. So we'll have 6x plus 3y equals to 6. And then we'll have 5x minus 3y equals 27. And then we will add them together. Okay, so we have 11x, 3 minus 3, 3 plus negative 3 is 0, and then 33. And so now we divide by 11 on both sides, and x will be 3. Okay, so now that we found x, we need to substitute this. This is the original variable that we solved for. So this variable has to go into both equations. So we put it back into the original equation. X is now 3 plus 1y equals 2. 6 plus y equals 2. Subtract 6 from both sides, and then y will equal negative 4. Okay, so that is the first equation. It works. You get a solution. If you did not get a solution, then you would have to look at your math, or maybe you possibly have a situation where it doesn't connect. 3y equals 27. 5 times 3 is 15. Minus 3y equals 27. When I substitute, you always see me use parentheses, so I keep my sign straight. That is going to be very important. Negative 3y equals 12. 12. Divide both sides by negative 3. And then y will equal negative 4. Okay, so y equals negative 4. Y equals negative 4. That tells us that our point of intersection is at 3, negative 4. And we already looked at graphing, so you have an idea of where they would intersect on a grid or a coordinate plane. Okay, so let's look at our second example. So we have, again, standard form of a line, ax plus by equals c. So both equations are in standard form, so we would look to eliminate. But if we look at our coefficients, the numbers in front of the variables, they are not the same, so it's not easy to eliminate. So what we have to do is run through our multiples. So 6 and 9. 6 times 2 is 12, times 3 is 18, 24, 30, 18, 27, 36, 45. Or we could run through our 4s and 5s. 4, 8, 12, 16, 20, 5, 10, 15, 20. And then you look for your common numbers. So here we will have to multiply by 5 and 4. And here we will have to multiply by 3 and 2. So it's always easier to deal with smaller numbers. So we're going to eliminate the x's. So we're going to multiply by 3 on this one, and then 2 on this one, and make equivalent systems. 3 times 6 is 18x minus 12y. 3 14s are 42. 2 times 9 is 18. 2 times 5 is 10. Equals -2. And remember, the number that you multiply has to multiply to every term inside the parentheses to have an equivalent. If you just multiply by one of the numbers or two of the numbers, it is not equivalent. It has to multiply to everything. So now, so we have the same sign, so we would subtract or multiply by -1. And be careful when you multiply. You do 18 minus 18, -12 minus 10, or, minus a positive, which is, it's a crazy way of thinking about it, but your teachers may tell you to distribute the -1 to every term and change the sign. So this should look like -18 minus 10y equals 2. Your teachers may tell you to do that. However you understand it is fine with me. But this -1, a negative means -1 if there's no number after it. And it has to, just like the 2 and the 3, it has to distribute to everything. So we divide by -22 on both sides. And then y equals -2. This is the variable that you solve for. So this is the variable that you will be substituting back into the original equations. And this is why we use parentheses. So we make sure we keep the sign straight. 6x plus 8 equals 14. Minus 8 minus 8. 6x equals 6. Divide by 6 on both sides. X equals 1. Okay, so now we had to go back into the other equation. When you do systems of equations, and I've said this before, you have to substitute the original variable you solve for into both equations. You can't just use one equation and expect it to work. It has to work into both equations. You must check systems of equations. Okay, 9x minus 10 equals -1. Add 10 to both sides. 9x equals 9. Divide by 9 on both sides. X equals 1. Okay, so our point. X always comes first. -2. Y always comes second. So what we're looking for is the point of intersection. So these are two different lines, and they will intersect at one point. Okay, so those are our two examples. So try to practice problems, and I will meet you at the end of the video. Okay, so you tried that. So if you run through your 3s and your 4s, you got 3, 6, 9, 12, 15, 18. You got 4, 8, 12, 16. So you multiply by 3 and 4 here, or 6 and 8. 12, 18, 24, 30, 16, 24, 32, 40. You get 24 as a common. So it looks like you'll be multiplying by 3 and 4 regardless. So it doesn't matter which one you multiply by. You'll get the same thing. 4 and 3 here. And so now we multiply. We distribute the 4 to every term. 12x plus 24y equals 12. And then here we get 12x equals 24y minus 15. Okay, this equation is not in standard form, so I'm going to move this y term over. So before I go any further, 12x plus 24y equals 12. 12x minus 24y equals negative 15. And so since the y's are opposite, I can add. I can get 24x, 24 plus negative 24, 0 equals, what's that? Negative 3. Divide by 24, divide by 24. X equals negative 1 over 8. Fractions. And I know how much you all love fractions. So this is the variable that we solve for. So this variable must go back into both equations. Okay, so here we go. Substituting 3 times negative 1/8, and this is why I substitute, because I use parentheses when this is why I use parentheses when I substitute, so I keep my sign straight. Okay. Add 3/8 to both sides. Add 3/8 to both sides. The beautiful thing about adding fractions to whole numbers is you just throw them together. But I must convert this into a improper fraction. So 3 times 8 is 24, plus 3 is 27, so this equals 27 over 8. Now divide both sides by 6. Y equals 27 over 8 times 1 over 6 equals 27 over 48. Divide by 3 over 3, which gives me 9 over 16. And I can't divide that any further. Okay, so we got 9/16. Let us see what the other equation gives us. 4 times negative 1 over 8 minus 8y equals negative 5. Negative 4 over 8 is negative 1/2. So I just did that fraction math real quick. Adding a half to both sides, adding a half to both sides. Negative 8y equals negative 4.5, which converts to 9 over 2. Divide both sides by negative 8. Divide both sides by negative 8. And I get y equals negative 9 over 2 times 1 over 8 gives me 9/16. Y equals 9/16. I get the same number. So that tells me that my point of intersection is negative 1 over 8, comma 9 over 16. When you're multiplying two negatives and make it positive, that's why the blue one came out positive. So be careful with your signs. Remember your signs. Okay, solve the system. Looking at the A's and the B's. So when we solve this system, the A's will be X, so they will come first when we write it in point form, and the B's will be Y, and they will come second. So we know the 4s and the 3s. We've done this a couple of times. We've seen 4 and 3, 8, 12, 3, 6, 9, 12. So if we're multiplying by 3 and 4, but let's check 2 and 5. 2, 4, 6, 8, 10, 5, 10. Okay. So we can multiply by 3 and 4, or we can multiply by 2 and 5. It doesn't matter which one you do. Just pick one and do it. I'm going to go with the 3s and the 4s. So I'm going to multiply this one by 3 and this one by 4. Okay. So 4 times A is 12. 4 times 3 is 12. 12A minus 6B equals 30. Get 12A plus 20B equals 18 and a half times 4. Is 74. Negative 74. Okay. So our 12s are the same, so we're going to subtract, and we have to change each sign. So 12A minus 6B equals 30. So negative 12A minus 20B equals positive 74. So you don't have to do this step over here, but some math teachers will teach you this way. I'm showing you this so that we don't get confused. Because the first time I tried this to make this video, I made the mistake of not changing the negative 74. So even I make mistakes. Negative 26B equals 104. Divide by negative 26 on both sides. And B will be negative 4. Since we solve for B, you know that B has to be substituted into both equations. So 4A minus 2, and this is why we use parentheses. Positive 8 equals 10. Subtract 8 from both sides. 4A equals 2. Divide by 4. Divide by 4. A equals 1/2. Okay. Substituting into the second equation. 3A plus 5 times negative 4 equals negative 18 and 1/2. Okay. So 3A minus 20 equals negative 36, 37, negative 37 over 2. Add 20 to both sides. Add 20. 20 comes out to 40 over 2, which equals 3 over 2. 3A equals 3/2. Divide by 3 on both sides. A equals, which is 3/2 times 1 over 3. Your 3's cancel out. You're left with 1/2. And A equals 1/2. Look at that. So our point of intersection is 1/2 comma negative 4. And for our final problem, so the first thing I'm going to do is move the y in this equation, because I did not write that out in the other ones. And then you got negative x plus 2y equals negative 7. Now here's a hint. You know that the 1 is here, so it's easier to get rid of the coefficient that has a 1 in front of it. But since the x has a 1 in front of it, I can multiply this one, this bottom one, by 5, or I can multiply the top one by 2. It's always easier to multiply by smaller numbers, so that's what I choose to do. And that's just me. It doesn't matter. You can do it by multiplying the bottom one by 5, and you will get the same results, provided that you make no mistakes. And so now we add 10 plus negative 1 is 9x. Negative 2 plus 2 is 0. And 16 plus negative 7 is 9. divide by 9, divide by 9, x equal to 1. Okay, so now what do? We substitute 1 into both equations. Again, using parentheses at all times. 5, let me erase that. So I get for writing too fast. Sometimes I write faster than my brain and I make mistakes. So please do not be distracted by my sloppy handwriting. And minus 8, 5 minus 8 is negative 3 equals y. Okay, well, let's check the second equation. Negative of 1 plus 2y equals negative 7. Add 1 to both sides. 2y equals negative 6. Divide by 2. Divide by 2. Y equals negative 3. Okay, so our x is 1 and our y is negative 3 because the 1 worked in both equations. We got the same solution for y. So we were lucky in all of these examples. The solutions, the systems had solutions, which means that they intersected in only one spot. I should have looked for examples where you had no solution or the same line. Same line solutions will be easy to see once you get some practice at doing it. So thank you for watching the video. Make sure you are practicing, and I will see you on the next video.